So this in the context of an API gateway, you'll need a custom authorizer whenever a static IAM policy is not flexible enough for your specific use case, or in case your API consumer can only rely on a legacy authentication method already in place, such as OAuth or SAML. In these cases, you can secure an API gateway endpoint by configuring and implementing a special Lambda function that will take care of generating a custom authorization policy based on the incoming request. The input of the Lambda function will be a specific authorization token given by an API consumer. The output will be cacheable policy document. The API gateway will evaluate the generated policy, cache it, and then process it. Then proceed with the current request. It will either deny or allow the request to the configured backend. Of course, executing the Lambda function will slow down your API call slightly, but the policy can be cached for up to an hour. The caching mechanism will make sure that you don't hit the custom authorizer. Thank you for the follow. It will make sure that you don't hit the custom authorizer too frequently, and by extension third-party applications as well, resulting in a faster API call. At runtime, it wouldn't be too different from a standard IAM-based authorization. Know that you can dynamically generate IAM policies based on your own internal logic, including a user-based permission, time-related access, endpoint-based restriction, or any external integration that you may think of. In the next step, you'll create an API backed by AWS Lambda and secure it with a custom authorizer. So we need to head over to Lambda. Create a function. It's going to be hello world. We're going to use node. Change the default execution role, use an existing, and it's going to be that one. Create the function. Yeah. We're not doing any advanced. Scroll down to the code source section, double click on the index.js file and overwrite the content with the following code. Did that actually change? It's literally the same code, I just took the comment out. Right, there we go. So, since you're using the default AWS Lambda proxy integration, your code has to return a specific structure containing the response status code and the body. The 200 status code will always signal success for the demonstration purpose of the lab. Click deploy at the top of the code source section to save the Lambda function. Scroll up to the function overview panel. Add a trigger. Where do we do that? Add a trigger, there we go. Select API gateway. We're going to choose a new API, followed by REST API, and we're going to select Open Security. This way that with open security setting, this will configure the API endpoint to not require any auth, and you'll use will be able to easily test it from a browser. This is for the purpose of training. You wouldn't normally open it up in a prod environment. Click Add in the lower right corner to trigger the configuration panel. Gosh. Cool. Click on API Gateway. And we can see the details. We'll observe that the public API endpoint is now available for us to test in the browser. Hello from Lambda. In this lab step, we'll have created the API gateway using the Lambda function and a gateway trigger. The API endpoint is open to public for ease of testing, and in the next lab step, you'll create a second Lambda function and implement the authorizer. So I need to run my check. Did we actually just do what I said I did? We did. Cool. So a Lambda custom authorizer is a normal function that receives an input of an authorization token. It returns a dynamically generated IAM policy. Assume that you want to integrate API gateway calls with your custom authentication system using a simple basic authorization mechanism. The following process would occur. Number one, clients would call your API with a standard HTTP authorization header, such as an authorization token. An API gateway would invoke the custom authorizer, passing the authorization token. The custom authorizer will validate the token with your internal authorization system, for example, another API reading from an RDS database. Based on the token validation result, a dynamic IAM policy would be generated and allowing or denying the API endpoint. Finally, the API gateway will evaluate the given policy to serve the incoming request and any subsequent requests during the configurable time to live. The custom authorizer logic is completely up to you. It could be a generic reusable Lambda function valid for all API resources or specifically reference API endpoints that you may want to allow or disallow for a given user. For example, you may have a different custom role in your internal system and each role might have access to only a subset of your APIs. This could be achieved with a static IAM role as well, but you would need to bind the internal role to the corresponding IAM role and keep the two systems within sync. With custom authorizer, you can avoid the synchronization and dynamically check if a given user's role at runtime. So now if we click on functions in the navigation breadcrumb, click create a function and we'll create a new Lambda function. This time we're going to use a blueprint. We're going to click on the radio button for use a blueprint. We've done that. Search for authorizer in the search bar. Where is the search bar? Blueprint. No, we want authorizer, not blueprint. What we're doing. Right, API custom user authorizer. Right, we're going to name it Hello World Authorizer. Going to use an existing role, Lambda basic execution. The blueprint is particularly useful because it will define a utility class so I'll find it. Called auth policy. There we go. This class greatly simplifies the generation of dynamic policies for your API because it already implements all the required logic to allow or deny a specific API endpoint or a HTTP method. For example, creating an allow all policy can be accomplished by the following snippet. Create policy. It's not even there. Okay, we'd add it. Okay, we add. Oh. So within our Lambda, so there, so that this bit we could put within a method. Can't edit it, but yeah, so it would basically where did I go? So it would like do this bit but within a function. The following is a more complex example that will generate a policy that denies access to a generic users list, also allows access to a specific user. Lab considers a simple use case that will use a variation of the first snippet with deny all methods so that you can quickly test the authorization policy. In the code source editor, double-click on Lambda function pi and replace the Lambda handler with the following code. Do we need to create it first? Yeah, there we go. I guess we need to create it. So create a function. Source code, there we go. So we'd replace Lambda handler. Yeah, so we want to replace that. Do not overwrite all of the code. You'll need to keep the HTTP verb and auth policy classes. So yeah, keep that. You can find the complete code here. The code that generates policy will allow all methods if the token value is Cloud Academy Labs. It will deny access to all methods otherwise. Remember, you will not invoke this function as an API gateway endpoint. You will use this Lambda function to authorize incoming API gateway requests. To save your changes, click on the deploy. So in this step, we have defined a Lambda function that implements custom logic as an API gateway custom authorizer. The logic grants full access to the authorization token in the machine in the request matches Cloud Academy Labs. All other requests are denied. During the next lab step, you'll see how to configure the API gateway to use the Lambda. So, so here we go. So yeah, if your auth token matches that, then it will just allow everything. Otherwise, it will kick you out. Right, so now we're going to set up the authorizer within the gateway by using the Lambda function that we just made. Go to API gateway. Hello World API. Click on Authorizer. Create an authorizer. Alright, the name is going to be that. Authorizer type Lambda.
Says, is this a free course?
It's not. That's why I'm not showing any of the content other than me doing the work, because I can't share it. Yeah, it's like the only way I can get around showing it off is me actually just working through the lab. I can't show you the actual steps.
How much was it?
I have no idea. Yeah, I get it through through work. But yeah, it's really good. The it's these guys. I'll give you a link to them.
Masek says, web link.
Yeah, I don't know what their costs are. It's probably based on yeah, a small team. So small team, £55 a month, $55 a month. Enterprise is different. But yeah, I use them.
Age says, thanks.
So yeah, I used them throughout my practitioner training, and it was like immeasurable how good it was. So yeah, I do recommend these guys. I love. So they'll give you the credentials. You don't need to like create your own AWS accounts. They give you all the creds so that you can spin up all the services that you need. So they must be taking like a minor hit in the sense that I'm spinning up resources, but it's not costing me anything, it's costing them. It does say actually when you create the thing, if you create like some boxes that are using the mega expensive tier like EC2 instances, they'll just ban your account because obviously they're pretty expensive. But yeah, it's pretty funny. As long as you stick to what the lab tells you, you're alright. Right, where were we? That's it, adding the authorizer. So lambda function, should be able to find it. We want the authorizer. Token source is authorization. Time to live 300. That's all correct. Right. Most important parameters in this form are the following. Token source, this is where the authorization token will be retrieved. By default, the standard HTTP authorization header will be used. Although you should leave the default setting here for the lab. Time to live it. Click on create auth. Right, then we click on the new authorizer. Click on test authorizer. So 401. So we just test emctest. That went 200 denied. And then if we put in Cloud Academy Lab 200 allow. Okay, so it's working. So in this step, we created and tested a custom authorizer. The authorizer is not enabled yet, so it will not apply to any API requests. We will enable it in the next step. So we need to, again, check I've actually done the work. Which I have. We can go on. Right, so now that we've created the authorizer, we'll attach it to the resources. Refresh the API Gateway console. Right, the authorizer will not appear until, click on resources on the left, followed by the any request. Then in the method request, we will edit. And then we want the authorization to be the authorizer. Save that. And redeploy. Default. Ignore any, so we don't need to do accords. So in this lab step, we've enabled the authorizer by configuring the method request authorization to use the authorizer, and we've deployed the change so that it's now live. So we should see this will reject me now once it starts using it. Should be. Let's try it with a new, where's the... where's the friggin... Oh, stages. There we go. Invoke URL. There we go. So now we're missing token. And if we do / hello world, still works, but it's because it's cached, I thought. Why is it doing it for that one? Hello from London. No, let's just keep serving it. Alright, well, I don't know why. That should come up with an unauthorized. If everything is properly configured, you can no longer get your API endpoint. You should receive a 401. So let's see, why is that? Why? Actually deploy it. Let's do method request using the authorizer. Deploy again. Stage default. Deploy. No, why does it still work? What the fuck? Right, let's try Lambda. Why are you not working? Right, oh, finally. Just had to run it a couple more times. Right, so now it unauthorized me. If everything is configured, you no longer get your GET request from the API endpoint. You'll receive a 401. In order to test the custom authorizer allows an authorized request, you need to include an authorization HTTP header. You can include the header using a variety of tools, including browser extensions like Postman, using a browser's development console, or using the curl command. For the lab, we use the hosted Linux command line. Alright, so do I get a new thing? Yes, I do. CA. Test the endpoint. So there we go. So it just gives me a command line. So if we run it with the header, then we get the result that we wanted. So that is working. Right, please note that both valid and invalid auth policies will be cached. Because the auths are cached, the function will not be called for the next 5 minutes. This means that you could temporarily have a misalignment, which is what we just had a minute ago, until the cache is cleared. In this step, you verify that the custom authorizer is generating the correct access policy. You may want to estimate the additional overhead due to Lambda processing. With curl, you can use the W option to output timing information. As you can actually see how much longer that additional auth takes. In the example of the lab, it could be within 25 milliseconds and 100 milliseconds worst case. Of course, the overhead will depend on your internal integration and might actually impact your API performance. In this case, you can always configure a longer time to life. Another interesting fact is your authorization logic is completely transparent from your actual Lambda function. Nevertheless, you might want to make it authorization aware and explicitly pass the principal ID via the API gateway mapping template. You can achieve this with the following. This might be useful. Yeah. Cool. So yeah, just making your business logic code aware of the auth state. Cool. That was actually it.